Now, before we really start going, do you guys have any questions? No. All right, sounds good. I keep the chat open, guys, so you can just drop in a question there if you have one. And so we left off talking about, turns out the body's just trying to maintain a certain temperature, and it's going to do whatever it can to regulate. Now, the only thing that your body can actually do to help you with extra energy loss is effectively going to be sweating. So that's using evaporation. And for every 1.5 liter we sweat out, we drop about 400 watts of heat. Now, obviously, this is really important when we're outside. This is important when we're exercising at high intensity. And then, obviously, if we're exercising just in a warmer environment than what our body would prefer. So that's where most of you guys tend to be comfortable in about a 70-odd degree room. But if you're actually working out, you'd almost prefer like a 60-some-odd degree room, or even lower if you're trying to minimize how much you're sweating. Now, obviously, if you have a thermostat, you can control that. But if you're in the great outdoors, you just got to deal with whatever nature's giving you on that day. And the other problem with evaporation is it turns out it comes down to what environmental factors were around. So if we can do unlimited amounts of convection and evaporation, we can literally be in a 200-degree room. I'm sure all of you guys at some point in your life have sat inside of a sauna. You're okay being inside of there, even though it's way, way hotter than what your body is, because you can evaporate. And at least if there's a breeze blowing over you, it's going to allow that energy to come off of you a little bit more efficiently. Now, it's our core temperature that's the bigger issue. If our core temperature gets to be too low or too high, we have issues. Too low, and literally our systems don't move as fast as they're supposed to. We can obviously have issues with performance and health in general. Now, on the other side is if we happen to be too hot, we're going to literally be baking our body from the inside, for lack of a better term. So we're literally going to take and start to denature protein inside of our body. And because of that, we're going to obviously break down and eventually possibly die from it if the temperature is high enough. Now, the problem is the actual sensor in our brain that detects when our body temperature is too high literally stops working once you get over 40 degrees Celsius. So this is one of those things when they say your fever is over 104, 105 degrees, where it just goes for broke, you stop sweating, we have things start to break down. Now, what controls this in the first point is going to be what's known as our preoptic anterior hypothalamus, okay? That's our thermostat. So temperature receptors in the body are going to detect if our temperature is too high. That happens, we're going to have vasodilation to the skin, and we're going to start sweating more. So we got better blood flow going to the skin, and we're sweating to bring that temperature back down. Now, if our body temperature is too low, when that's detected, our body is going to then start doing vasoconstriction to the skin, along with it's going to start shivering. Now, the problem with that vasoconstriction when we're around the cold is, yes, it's doing its best to try to keep the warmer temperature deep inside of the body, which is where all of our important internal organs are. However, what happens with this vasoconstriction to our skin and to really our peripheral limbs? What can happen? Anybody?
Can you ask the question again?
Yeah. If we're having vasoconstriction to the skin and to our peripheral limbs, because it's very cold, what can that set us up for?
Frostbite.
Bingo. Frostbite. And where does frostbite typically strike first in a human body?
The fingers.
Bingo. Is that Tori?
Yeah.
Figure the Canadian knows what frostbite is. Is that something you ever encountered growing up? Like any of your friends ever get mild frostbite or anything like that?
No, where I live, it gets colder in Kentucky than it does in my place.
Oh.
Yeah, it's like it barely snows here, maybe like once every year.
Interesting. Learn something new. Cool. So keep this in mind that by giving ourselves that vasodilation or vasoconstriction, we're going to increase or decrease heat loss. Now, when it comes to vasodilation, like obviously I wear rings. Any of you guys ever notice when you're outside and it's hot that whenever you get done, it's hard to take your rings off from the vasodilation? A couple of you guys have had that occur before. And then the opposite, where obviously with vasoconstriction, whenever we're cold, so we can keep that heat in. Now, obviously that's the physiological variant. Now, what type of body type in general is going to do a better job of thermoregulation, specifically bringing your temperature down? Someone who happens to be very stout or someone that happens to be very spindly? What do you think, Gracie?
Wait, you're breaking in and out. What was it?
Oh, is the sound not coming through too good today, guys?
Well, my Wi-Fi just sucks.
Yeah, the internet in our house is not great either. Okay, so who's going to do a better job of bringing their body temperature down? Someone that happens to be very long-limbed and slender, or someone that's very stout and compact?
Long-limbed and slender.
Bingo, because your surface area to body mass ratio is better, so you can get that better temperature exchange. Problem with it, though, is obviously when you're in a cold environment, individuals that are more compact are actually going to do a better job of retaining body heat. Now, obviously, we're going to be sweating because of heat production. Our sympathetic nervous system is playing into this a little bit. And it turns out, once again, that pre-optic anterior hypothalamus is going to be sensing these changes, which in turn is going to get us to sweat more. Now, shivering is going to occur, which is effectively just uncontrolled contractions and relaxation in order to generate some more body heat. I'm sure all of you guys have had that, had your teeth chattering or otherwise, where it's a way to generate more heat, because what percentage of our energy production is actually wasted as heat, guys? Either Jake, what do you guys think?
Crap. Can you say the question again?
Yeah. When we're producing energy to just exercise, what percent of that energy production is really just wasted as heat energy?
I would say probably over half, like 60%.
Yeah, where it's getting closer to about 70%. The body's pretty inefficient. So hence all the shivering, that's just going to once again, releasing energy that's not performing physical work, but that heat that it's producing through the contraction is going to help keep the body temperature up. Now, when it comes to the endocrine functioning, the thyroid gland is going to be what's effectively our resting metabolic rate, and specifically the production of our thyroid hormone might increase a little bit if we're exposed consistently to cold environments, which actually causes you to have a greater caloric demand, which is kind of funny because you hear people talk about like, oh, I'm going to go, sweat it out and increase my energy production. In a warmer room, it actually requires less energy to keep your body that temperature. If anything, when it's obviously very hot, now you have to thermoregulate, which is going to take a little bit more. But if you really wanted to burn more calories, just hang out outside when it's cold, wearing as little clothing as you can legally get away with, and your body's going to have to work harder to keep you warm. So now the thing you need to keep in mind, guys, is like anything else, we have finite abilities to do everything. And specifically when it comes to our cardiovascular performance, we're going to see that like anything else, we only have a maximal cardiac output. So if we have to be spending a lot of that output to the muscles for exercise, it's going to be much harder to thermoregulate because we don't have as much left over to send to the skin that we can also sweat out. So think back to cardiovascular drift that we talked about earlier. Because like anything else, we're going to vasoconstrict away from the things we don't need. However, as we keep sweating out more and more fluid, our blood volume is going to go down, which means our heart rate has to go up since our stroke volume is also declining. So like anything else, the body has to prioritize what's more important, the potential to overheat or the potential to be eaten by something. And the body's going to prioritize the whole not getting eaten. The problem is that's what can lead us into heat illness and heat injury. And once again, keep in mind, your body has physiological limits. So once you go beyond them, the safety is effectively off. And in this example, we're talking again about how your brain, literally once your temperature gets to be so high, no longer is thermoregulating. So you can literally have individuals that stop sweating, go into injury and illness, and or the performance is going to be rate limited. And that once you get over a certain temperature, the body is effectively going to try to diminish your performance so you effectively don't hurt yourself. Now, some people can go over that. It's pretty rare, and obviously can be lethal whenever they do so. Now, if you guys look at the graphs on the right, you can see how you're going to have those temperature effects on performance. So obviously having the same individual exercise in a effectively normal temperature room to a hot room, you can see how their body temperature goes up. Their cardiac output is not going to be as high. Notice they finish and they have a lot lower VO2, and along with their stroke volume, and they have to compensate by having that higher heart rate in order to maintain the same exercise load. Now, do keep in mind, guys, if we talked about how you measure temperature in humans when they're exercising?
I don't think so.
It's
You got to log in. So thankfully, I wasn't there for this, but at Kansas, they were doing temperature probe work. Now, guys, read up there. Can you guys read the slide well enough, or is it not big enough that you can see it too well? So if we're looking at this graph right here, what form of temperature is that right there?
Celsius?
rectal.
Yes, that's rectal. So in order to take someone's rectal temperature, you effectively have a probe that you put in there that honestly the probe is like maybe about the size of this like little pen cap and a long wire. Now the wire at the end has a double prong that you plug into the machine. Once again, previous to my time, they had a subject come into the lab where they give them their temperature probe and like, go to the bathroom, put a couple, inches of line up there and then come back out. Well, the person goes in, and is in the bathroom for like 5-10 minutes and they're kind of like, Jesus, what's this person doing? And when they walk out, they've got the wires running through their shorts and they're holding that thin probe end. And they're like, man, that really is uncomfortable. You got to like give us more lubricant or something because I did not enjoy that. They're like, oh God. So from then on out, they needed to always establish the thin little ball that goes in there. That's what measures your temperature, not the angry prongs that you're putting into it like it's an electrical socket inside of yourself. So the joys of science. But anytime you see something is measured, you should always ask yourself, how did they measure that? Now, obviously, when we're sweating, we're going to be losing fluid, specifically, obviously, water. Now, we're also losing electrolytes. Aside from sodium and chloride, we're losing potassium, we're losing calcium, we're losing magnesium to a certain extent, and even zinc. And all of those things are going to effectively cause not just diminishments of performance, but possible risks for cramping, depending on how much, and then diminished recovery. Now, the other thing to keep in mind is depending on how much we're sweating and how good of condition we're in, we're going to be losing greater or lesser amounts of sodium and chloride. So individuals that are in better shape, they do 3 things better when it comes to sweating. They sweat more, they sweat faster, so earlier on in the exercise training, and they sweat less concentrated, meaning there's going to be less sodium and chloride in there, so they're less likely to have issues with cramping due to fluid loss from that exercise endeavor they were doing. So individuals, when they get to be in better shape, literally do a better job of sweating overall. So now the big key is, like we talked about last time with acclimation, in order to get better at all of these things, you have to be exposed to that temperature. So you have to go out there and you have to effectively exercise to certain degrees, so that way we can go ahead and keep performance up. Now, this in turn is going to affect our endocrine system. So our adrenal cortex and our posterior pituitary are going to be releasing antidiuretic hormone, aldosterone, and even a little bit of vasopressin, so that we're going to be retaining both sodium and water. So literally, you're going to be paying less. And I'm sure every single one of you guys has had a long day where you're outside, and then you maybe didn't even think about it, but it obviously probably happened to you where it's like, man, I've been outside for like 6 or 7 hours and I've never had to go to the bathroom once. And that's going to be an effect of literally this hormonal balance that's being changed in order so that your body is going to retain that sodium and retain that antidiuretic hormone. Now, here's the big key when it comes to hormonal control of electrolytes. Notice, folks, it only is specific for sodium, and it's only specific for retaining sodium. The human body does not have a good way to excrete excess sodium. And this lends itself to one of the bigger public health issues that we have these days outside of the freaking coronavirus. And what do you think that is when it comes to sodium in a human body?
Well, people who eat a lot of salt, it leads to like heart problems, doesn't it?
Now, it can lead to increased blood pressure, specifically in about 1/3 of the population is very salt sensitive. And because of that, yes, if they have too much sodium, their blood pressure is going to go up, and blood pressure is what's referred to as the silent killer. Like, one thing to keep in mind, guys, and I'm an exercise physiologist, I'm not an immunologist, and I understand a little bit of statistics, but I'm definitely not going to ever call myself an epidemiologist. When people say like about what's currently going on, like, oh, it's not that dangerous, as long as you don't have any other comorbidities, you're fine. But then you realize that about 1/3 of the population is high blood pressure, which is a comorbidity, and about 1/3 of the population is also pre-diabetic, which is also a comorbidity. And both of those, now mind you, a lot of there's overlap if you think of Venn diagrams there with those people, and most of them don't know who they are. So in theory, 1/3 of the American population should definitely avoid getting this because it could, axe them. So when it comes to sodium, I'm not worried about sodium intake with pretty much any of you guys. And why is that?
We drink water.
Yes, you drink water, and then I'm sure a number of you drink alcohol too. You got to cope with being back home with your parents to the best of your ability.
I don't know. I was just thinking how when you go to the doctor and they tell you to drink water and take in more salt to retain the water. That's kind of what I was going with that.
You're right. That could be one of them, but it's not so much I'm worried about your water intake to sodium ratio. Most people tend to do a pretty good job of regulating how much fluid they need, just following their own basic thirst. As long as you're drinking water whenever you're thirsty, you're going to be fine. But it comes down to another key thing that you guys do that your average American doesn't.
Exercise.
Bingo. So as long as you guys are working out and sweating, you're losing that excess sodium, because that's how our body loses excess sodium for the most part, is going to be through sweating it out. Now, your average American that's going from one climate-controlled environment to another climate-controlled environment, they're not ever really having to sweat that much, So they're never really getting rid of that excess sodium. That's why hormonally, the human body only has a way to retain sodium. Because if you think about humans on the savanna of Africa, yeah, you're gonna be sweating a damn lot. And rarely would you ever come across, you know, a wild field of potato chips or French fries or salted pretzels. Sodium, and specifically, you know, a high sodium diet was pretty darn rare. And so it was nothing that had ever be hormonally controlled. Instead, the word or the problem said was scarcity. And unfortunately, with the American diet, on average, we have an overabundance of some nutrients compared to what our body's meant to go through and take care of. But for you guys as athletes, never, ever, ever follow those lower sodium recommendations, because it turns out, once again, you guys have those higher demands because you are sweating it out, because you do have that turnover. If you go on a low salt diet, for the most part, you're going to perform worse. So always keep in mind, what are the mechanisms of what we're working with, and how does that apply specifically to the individuals we're working with? So if you have somebody that naturally has perhaps a little bit of high blood pressure, a little bit too much sodium, or they enjoy sodium too much, by no means am I offering medical advice because I didn't go to trade school. But keep in mind, it's good for them to go out and literally sweat, because that will help us eliminate excess minerals. And actually, kind of funny, that's how the body removes some heavy metals and some like BPA and other toxins to a lesser extent, but let's not get woo-woo here. So there's a number of things we need to keep in mind when we're going outside. So obviously, how much heat are we going to be producing in the exercise we're doing? How warm is it out there? What is the humidity? Okay, ambient water vapor pressure, but let's be honest, guys, it's the humidity. Because how many of you have had a chance to be out in the desert? Like, this would be out west, or specifically in the Southwest, in a legitimately dry environment. Any of you guys ever had that chance? Nope. Okay. In reality, okay, well, all of you guys have at least experienced a really muggy Kentucky day where it might only be 82 degrees, but it's 90 something percent humidity, and you literally walk outside and you just feel damp. Like, you sweat and then your shirt is 3 more pounds because it just stays on you because it never evaporates. And so that's the weird thing about being in the Southwest that I did not realize until I ever had a few chances to get out to the desert. I was like, why is my shirt never getting wet? I'm used to, like, you know, working out for 2 seconds in Kentucky, and then all of a sudden, you know, my shirt once again weighs like 2 or 3 pounds because I'm sweating through everything. Because it turns out the humidity really helps with your ability to remove that energy. Now, air velocity, meaning is there wind? Are there other? Yes, Tinks, I know, girl. I know. I opened the window so she could look outside. This working from home is heck. And then when we talk about radiant heat sources, what would you guys think of is probably gonna be the biggest one to deal with when you're working out outside?
The sun.
Bingo. So you guys know, anytime you've had to play a sport on a really sunny day with no cloud cover whatsoever, you can literally feel that sun beating down on you. Like, you can actually feel your body temperature going. Now, it's great in the winter when you go outside and the sun's on your face and, like, okay, it feels a little bit nicer. But in the dead of summer, like, that's pretty rough. And then the last variable that we can control is the clothing. So if we're outside just a t-shirt and shorts, turns out we're going to be able to thermoregulate pretty well. Anytime I decide to do the dumb thing known as long distance running, it turns out I'm literally just running around in short shorts because I want to have as much, yes, I know, Tinks, I know, girl, to have as much skin effectively exposed so that I can, A, maybe catch a tan for once in my life, but more importantly, B, I can thermoregulate as much as I can. Sorry, getting back to it. Now, all of these things combined are going to give us that heat stress. Now, when we're talking about measuring it, it's important not just to have the temperature, but what's known as the wet bulb globe temperature. So what this does is it gives us the idea of effectively how much extra temperature differential can we get thanks to the ability to sweat. It's like I never pet them. It's like I never pet them. So when we happen to be out in these temperatures, the globe is giving you the idea of effectively how much of the energy from radiation is coming down. So AKA, when the sun is beating down on something consistently, how much higher is the temperature? So a great example of this, guys, is if any of you guys ever made the poor decision to walk on a beach on a really sunny day, or to try to walk on like legitimate pavement on a really sunny day.
It burns.
Exactly, because of how much energy those surfaces are going to absorb. And then obviously you are now conducting that into your own skin. And then same thing if you have to play a sport on a turf. I remember having to do up downs for football, and it turns out the best part was actually the running. The worst part was having to be right on the ground, breathing the hot air right off of the turf because of the amount of energy that was obviously in it and then being brought over to you. So when it comes to the health risks that can occur from the temperature, well, the first one we're going to have is the heat cramps. Okay, this isn't that bad, but it still hurts. And we're going to have issues with cramping, and this is going to be due to issues with fluid shifts, specifically also that sodium losses. And individuals that are very heavy sweaters, there's a genetic component for that. And remember also in adaptation, especially if we aren't doing a really good job of hydrating before we're going to go out for those practices. So any of you guys ever had issues with heat cramps?
I haven't, but I played with a few guys that would like during the summer get like full body cramps. And I was gonna ask the question, like, is that because they like are just heavier sweaters than like other people, or is that just like, I don't know, like it felt like he would do everything in his power to like try to prevent it, and then it would happen.
Okay, how big was the guy?
He was probably like 6'2", like 190.
Okay,
like
so
that.
he was a tall dude, but he wasn't like a big dude.
Yeah.
Interesting. And then he was doing his best with his fluids. He was staying on top of his electrolytes. Was he trying to like fluid
Mhm.
beforehand, like maybe throwing in some glycerol or something else for some hyperhydration?
I mean, he pretty much did everything. Like he tried everything, and it like would still happen to him.
Yeah, like I said, there is definitely going to be a genetic component to everything. And as a guy that's been married for a number of years, never use the word everything, never use the word always or never, because there's always an exception. Now, given all the things that your friend tried, he obviously didn't find a solution to his problem. Now, that doesn't mean there is no solution for his problem. That just means me as a, practitioner, so to speak, would keep experimenting to figure out what's going to be the solution for his problem. Because it could be, now, some folks need not just a high, but a crazy high sodium intake in order to offset this, or it could be not getting enough potassium, and it could be potentially not getting enough magnesium. So obviously the body's pretty complicated. We got a lot of minerals that we need every day, along with the fluid on top of it. And like anything else, he could have been prioritizing perhaps the sodium and the potassium so much at the effectively neglect of the magnesium, and or he was doing his fluid in just really big boluses as opposed to trying to do smaller intakes over a longer period of time. That way he's going to have better maintenance of that fluid level. So hope he figures it out, but like anything else, keep experimenting. The next level you're going to have is heat exhaustion, and this is where you can start to have some major physiological issues. And turns out this is because you're really dehydrated from all the sweating you're doing. And because the amount of sweating you have to have going to your skin compared to the amount of cardiac output that needs to go to your skin so you can sweat compared to the amount of cardiac output needed to your muscles, you can't do both at the same time. And so you're going to have issues with thermoregulation. I worked as a stonemason for a number of summers during college, and it was definitely once or twice that I had issues with this, and I was like, okay, I understand enough that I need to go hang out in the shade for a little bit and just drink some fluid. And then same thing would happen to some of my coworkers because it was just hot and muggy perpetually in St. Louis. Now, the next one is the most dangerous, obviously, and that is going to be heat stroke. And this is where literally you stop sweating. You no longer have that thermoregulatory ability. And now we're starting to talk about people being really off because their brain is effectively baking. And if they don't get in and get their temperature brought down, they're going to have some major issues. I used to work as an umpire over the summers. I used to just work as an umpire in general. And it would be over the summer when we would have tournaments that usually our first or second tournament sometime in like late May, early June, once again back home in St. Louis, that we would usually have usually one or two younger umpires go down getting damn close to heat stroke. Like literally they would be the plate umpire, they'd be set up, watching the pitch, and then you just see him crash down to the ground. Like, because effectively, not just is it hot, but then you have that clothing issue because you're wearing the protective gear on top of it. You getting the radiation from the sun because you're definitely not in shade. And turns out you're going to have issues with really risking some major issues. So the easiest way that we can prevent this is, well, don't be really working out outside if it's really hot out there. Make sure that if we're working with teams that we're trying to practice really early in the day or late in the day, aka around the warmest times of the day, and never be a jerk about fluids. Make sure that we're always taking it in. Make sure that we're taking breaks to take fluids in. And if anything, trying to make sure that you're keeping track of some physiological values with your athletes. So this is sometimes where pre-post practice weights can be really useful to figure out, okay, are we around where we really should be? Now, with minimizing clothing, that is obviously a liability. As a catcher in baseball or softball or a football player, you don't want to be running around without any protective gear on. Like, you definitely want to be wearing an appropriate amount to keep yourself safe. And then that gear not just traps your own body with heat, so you're radiating the heat back on yourself, but it severely limits your body's ability to use evaporation. So when and wherever we can, make sure that we're making better choices with putting our athletes out there so that we're going to minimize these risks. Now, when we do talk about fluids, how many of you guys have had to drink warm water during practice before?
Me.
It's a great time, isn't it?
No.
Come on, everyone knows like one of the most refreshing tastes on earth is warm hose water. Has that nice, like, kind of weird rubbery aftertaste. It's great, right? So it doesn't mean we need to be buying them only, sports drinks and whatnot, but like anything else, just making sure we've got water and it's cold. And notice, guys, we want to make sure that we are trying to keep up our fluid effectively that we're giving them to have them take in before the next practice or obviously over the course of the day based upon that weight loss. And that's on top of what they normally would be drinking otherwise. Now, just being aware of heat illness signs. So when you start to have issues with like cramp, confusion, dehydration, just a simple education thing with the athletes so they know, okay, like when you start to feel this, you start to feel that, like, all right, let's make sure that we're aware. And then, when in doubt, making good decisions whenever you're working with those athletes to not put them out into harm's way if you can help it. Now, what we need to focus on with individuals that don't have an option is acclimation. And that's, once again, getting our body used to it. Now, acclimation is going to be that thing that takes us typically about a week to 2 weeks. We need to be out in the heat. We need to start off very low in intensity, and then we need to go ahead and slowly increase our exercise intensity so our body is going to do a better job of sweating along with regulating that body temperature. Now, this in turn is going to help increase our plasma levels. So we've literally got more fluid, and this is because we literally are producing more albumin and retaining a little bit more fluid than we would have otherwise. And then this is going to allow us to keep that lower heart rate while still maintaining that higher cardiac output. So we're going to be a better athlete along with decreasing our risks of getting injured due to dehydration related, or having a lower performance because of that mild heat injury, heat illness, that's going to cause us to make worse tactical decisions and potentially cause harm. Now, notice, guys, for the sweat rate, looking at the temperature, looking at the heart rate, how quickly that's going to decline, and then how quickly the heart rate's going to go up in literally just over a week. But once again, they have to be outside, and you've got to get out there for a couple hours. It's not like you just walk out there for a minute or two and like, okay, I'm heat adapted. And when we say low intensity, let's say you fly your athletes down there or you bus them down there. What would be your low level activity you'd want to do with your athletes for the first day when you're now in a very hot environment?
For like a football team, you could do like a light walkthrough in the evening with no pads.
Yeah, you could do a light walkthrough. Or, if you're in a new place, you could always just take the team out and you guys go walk around. It doesn't have to be even true structured practice. It can be like, hey, we're just going to go outside and we're going to go walk over this outdoor location, and that you're going to be exposed to the weather out there, and you're going to obviously be getting a small metabolic demand on the body. And then the next day, maybe do that walkthrough practice, maybe do just a real light skills practice, something that's going to be a little bit more up-tempo, and then slowly transitioning into full scrimmage game type scenarios that really are going to be stressing the body. And then you're right, going from the ends of the day to closer what that true competition time is going to be. The neighbors just got home. Now, what we're going to find with cold habituation is we got to get out there enough without having massive heat loss. So we're just going to be getting exposed to the temperature, but we're not getting to the point where we're starting to shiver and fall apart. Now, what we're going to find is we're going to have that vasoconstriction. Our shivering is not going to happen as quickly, and we're going to allow our core temperature to go down a bit lower. Now, over a long enough period of time, now we're actually going to be increasing the resting metabolic rate and then possibly affecting our heat production. And so this is nothing that I have tried, but this is something that I heard, that I've read about. It was somebody that they might be a charlatan, so I'm not going to be the biggest proponent of this idea, but I'm a scientist, so I'm always interested in trying things out. But for a weight loss program is literally changing nothing about your diet or exercise, but taking full body ice baths every single day. So that way you have that shivering effect of thermogenesis. In theory, you have got greater brown fat activation or development, and then that allows you to burn more calories at rest so that you literally can lose more weight, and specifically by burning fat. Now, I'm not quite sure if they're talking out of this orifice or this one down here, but it at least is an interesting concept of literally trying to do this through cold exposure. So if we weren't doing the wonders of social distancing, I always offer to the students, if you want to go and we can do ice baths down in the athlete training room and see if that helps. I'm not afraid, not enthused, but not afraid. But oh darn, I guess we can all say we wanted to do it, but we couldn't do it because, the realities of our situation. So now, as far as exercising the cold, don't be an idiot. We don't want to cause hypothermia. We do want to make sure that we are aware of how body composition is going to help or hinder this. Leaner individuals obviously are going to have that lower amount of insulation, along with they're going to have that body surface area to mass ratio that's lower, so that they in turn are going to have, there's going to be higher because they've got more surface area compared to the mass. They're going to have a greater amount of heat loss. And so we have to be aware of it. Now, when it comes to children versus adults versus elderly, your average child effectively is going to have a greater amount of area to the mass ratio. So literally it's easier for them to have a lot more heat loss. And then elderly, because they tend to be smaller with the limbs just due to less muscle mass and otherwise, they also are going to have issues with greater heat loss. And then when it comes to men versus women, on average, women actually do better with thermoregulation in the cold than men. And that's due to effectively more even distribution of adipose and the fact that your average female doesn't have really freaky long arms and long legs relative to their height. And so more of their heat's going to stay in the midline of the body. Now, the problem is, guys, we're looking at this from the perspective of just don't die of hypothermia, which is not what you're trying to work with your athletes. Instead, if we're trying to work with our athletes, what do we just need to be aware of if we're going to exercise in the cold?
The temperature.
Yeah, and if, well, we're going to be able to figure out if the temperature's cold or otherwise, what are we going to tell our athletes to do, or what are we going to do ourselves?
Just layer up.
Bingo. And making sure that we're trying to wear things that effectively are more moisture wicking, because like anything else, we don't want to have this directly up against ourselves. Now, keep in mind, which we had a really soft winter. It never really got to be that cold, but be aware of the wind chill, because like anything else, it's not just the temperature outside, but it's also the wind velocity that's going to cause the ambient temperature to feel even lower than it really is. And notice, guys, your freezing risk for effectively the amount of time you have to be exposed, where you're going to have issues with potentially literally freezing limbs and otherwise. So notice, now this is negative degrees centigrade. So until we're starting to get at about negative 15 and really negative 20, so now we're getting closer to like single digit weather outside, unless the wind is ripping by at an insane velocity, you're probably going to be okay. You'll be miserable as long as you're still moving around, but you're going to be okay. The thing that really gets you in trouble if you're out in the cold is water. So if you get wet, so this can be, obviously you sweat a lot, you're wearing a bunch of cotton clothing, now that clothing is wet, and then now you're not moving as much, and that's going to cause your temperature to go down rapidly. Or you fall in water, you happen to be inside of water. In fact, initially a lot of this research was military, specifically figuring out how long a GI could be in water to this height, to that height, to this height, without having issues with hypothermia. So, fun fact for Jake, I literally got to read those original tables. So now whenever I'm an idiot hiking around with Norbert and step in a creek, I'm like, okay, I am now in ankle deep water. And it turns out, as long as I'm not in this for half an hour while standing here, wearing just these boots, I'm going to be fine. I'm just going to be miserable. So keep in mind, guys, it's not just the temperature, but obviously it's that wind chill, and then obviously what's going on with water. Now, how is this affecting us? Well, what you guys already know. Turns out your muscles are not going to perform as well when they're cold. So we're actually literally going to not be able to produce as much force and or power, okay? Along with, it turns out we're going to have issues with an increase in friction in our synovial fluid. So that's why your hands feel a little creaky when they're really cold. Same thing might happen with some of your other joints. And we're going to have issues with having fatigue come earlier on, because not only have vasoconstriction to the skin, we got vasoconstriction to our fat. So because of that, we're relying more on glycogen as a fuel source, along with, it turns out, we are going to be being effectively less efficient with our movements due to those tissues being cold. And so everything is actually costing us more to do. So keep in mind, you're not going to be able to use fat as well. We're going to rely more on glucose. And it turns out we are going to have the same type of situation where if the body temperature gets to be too low, we're literally going to shut down our thermoregulatory effects. This is why, sadly, on occasion, when you hear people dying of cold exposure, they effectively, you hear about stories of them like literally being found effectively naked or just in their underwear. And the reason for it is literally they no longer feel cold. So like, why am I wearing this parka and these snow pants and everything else? Like, I'm just going to be comfortable. So it's very paradoxical, but it's literally because it turns out you're not going to be able to feel that anymore. Now, some folks might have a little bit of cold related asthma, just a little bit uncomfortable breathing the cold air, but it's not actually doing any damage to your lungs. Like, you'll be okay. And it might slow down our ventilatory rate simply because of that slight discomfort, but we're not causing issues. Now, if we do have issues with hypothermia, turns out we do want to make sure that we're brought in from the cold and brought our temperature up. unless it's severe. And if anything, we want to make sure that we gently bring the body temperature up. If you do it too quickly, you can literally develop a heart arrhythmia, which can in turn obviously be borderline fatal. And then at the end of the day, make sure you take them to the hospital. And if you have frostbite, for the love of God, definitely go into the hospital, because now we literally have frozen that tissue, which is going to cause the tissue to die if we're not really careful and quickly. And then if we don't get that taken care of, then it turns out it's going to get infected with gangrene. If any of you guys are trying to do a diet right now, just Google images gangrene. It really helps with losing any interest in eating for a while. And make sure that, once again, we are just being smart, making sure that we're not going to be exposing athletes unnecessarily to very low temperatures. And we're going to make sure that we're wearing appropriate clothing for whether we're exercising in the heat or the cold. And the body's going to do what it can physiologically to help deal with this, but really all it can do is sweat, shiver, and vasoconstrict. That's it. So our best bet is just to make better tactical decisions with the clothing that we're wearing, with the time that we're training, with the amount of exposure we're allowing ourselves to have. And that's going to give us way better effects than just trying to rely purely on the physiological. Because we can always do the research of figuring out what's the normal temperature in this area. We can look at weather forecasts for what the temperature range might be, so we're prepared on either side of the coin, and then doing our best to expose ourselves to temperatures near that, and then trying to give ourselves that chance. Now, let's say, for example, right now you're going from having someone, well, let's imagine the world is still functioning and you can go places. So you've got to be training here in Kentucky, and then you're going to go down and run a half marathon in Central America, where right now it's, I'm just throwing this out there, it's probably not accurate, 90 degrees and like 90% humidity. What can you do to at least start to get your body used to exercising in warmer temperatures, even though it's not that warm here? Yes, Bree. Exercising in layers. Specifically, what we want to do. Anybody?
I got nothing.
You can wear a hat.
Say it louder.
You can wear like a ball hat, a ball cap.
Yeah, you can wear a hat. Okay, so if we're trying to get used to exercising in warmer temperatures and it's not available, what can you do clothing-wise to make it feel like you're in a warmer environment?
Wear lots of clothes.
Try to look like Ralphie from A Christmas Story. Throw on a bunch of sweats, throw on a bunch of like long underwear, otherwise something that's going to make it feel like it's a lot warmer outside than it really is. So that way your body does have to sweat, and you're going to start to acclimate a little bit, even though you're not actually in it. I mean, if you guys have a sauna in your house that you can go and just, try to drag like an exercise bike inside of and ride at a low intensity so you can get the thermic stress while you're doing something metabolically taxing, great. But for the rest of us, it's probably just going to be throwing on more layers and then exercising, purposefully keeping them on to where we do feel uncomfortable with the temperature. And then slowly scaling that upwards. So it's not the same as obviously being in that environment, but at least it's giving you a lot of those same type of stressors, so your body's gonna have to get prepared. Now, what questions do you guys have for me for anything that we went through today, talking about dealing with different types of thermic stressors, or anything about the class in general?
So back when you were talking about drinking cold water, I always heard that it was like it required more energy to take in cold water when you're exercising. Is that true?
Okay, so great question, Taylor. No, it's osmosis is how you get water into your body. But what's really useful is it's just temperature exchange. So for example, that ice bath, if I'm, right now, body temperature of 98.6, whatever, hop in an ice bath. Immediately, the ice bath is a lot colder than I am. So temperature from my body is now radiating out through effectively convection, rapidly bringing my temperature down a little bit and increasing the temperature of the water I'm around. Now, same thing happens when you drink really cold water. As you're drinking that water, not just is that giving you more fluid so you can sweat it out, but it's cold. And so your body heats it up, aka you lose heat to that water, so it actually helps you bring your body temperature down. That's why, folks will put a cold compress on their neck, cold compress on their head, anything along those lines so they can have that better amount of energy exchange. So as long as the water isn't so cold that it's giving you like a brain freeze or it's physically uncomfortable to drink it, however cold you can tolerate is actually probably going to help you out if we're doing it specifically as an adjunctive therapy to help make exercising the heat less awful. So,
Okay.
good question. Anything else you guys want to go ahead and go through?
With that example, with wearing more layers in your own environment to acclimate to South Africa, if you wore those layers and just took them off to run around in your own climate, would that improve the performance?
Okay, now you got to keep in mind, it comes down to what are you really trying to adapt to. So if you're already in shape, any extra stressor like that is probably taking away from just getting literally tactically better at your sport, or what you're about to actually have to go ahead and do. So you can go ahead and do that if you want. However, I would suggest it comes down to what you're really trying to deal with. And so the training with all the extra gear on top of you, a big part of a lot of sports is just tactics of pacing, of understanding when you can go up higher and lower intensity. And so just getting better at sweating isn't really going to be useful for most athletes if they're already aware and adapted to those environments that are around them. Now, it's one of those things like if you know you're going to go from normal to it's going to be really hot or really cold there, you want to do what you can to prepare for it. I've heard of examples of folks that are trying to get ready to do like mountaineering, like summiting Everest and things along those lines. They will literally go and try to, take those ice baths to get used to the cold exposure, and or they'll try to get into like big like meat lockers, like walk-in freezers, and try to work out inside of them so that they get much more, they get more habituated to being in cold environments. Plus, you get to look cool if you're Rocky punching a piece of beef in a meat locker. So, any other questions? Doesn't necessarily have to be, once again, about this topic. Anything we've covered in the class so far? All right, guys. Well, you guys have yourselves a good one. We'll be back on Wednesday, and then we're going to go and start talking about training for sport, which is going to be fun. And then after that, we're going to be talking about nutrition, and then we finish up talking about drugs. And yeah, moseying on through. You guys are making this really easy. We're going through this information so quickly. Man, Mike could just give you the final early and have you done with this class in April instead of May. How's that sound?
Good.
That's what they all say. So they got to take that final. No, you guys have yourselves a great day. And yeah, miss seeing you guys in person. Stay safe out there. And yeah, talk to you guys later. Bye-bye.